Alright, we have come to the last section in the chapter, and so this is 1.6, and really what we're going to deal with is the absolute value in an equation, and we're going to deal with absolute value involving inequalities. So let's go with it here. Just a quick definition. Absolute value, you remember, is just it always makes the number positive. So if you have the absolute value of a, which is already positive, it just stays the same. There's no change to the number itself. If the number itself is a negative number, then what we do is we take the opposite of it. But really, in the real sense of it all, what is the absolute value by definition or by concept? It really is this here. It's just the distance from a number back to 0, or from 0 to that number. And so in the case of absolute value of 5, really it's the distance from 5 back down to 0. In this case it's going to be 5. So in the instance of -3, the distance from -3 to 0, or from 0 to -3, it's going to be 3. So notice, because distance can never be negative, the negative sign really just drops off. Okay, but that's sort of it. So let's go to this one right here. So how do we do this algebraically? How do we solve or an absolute value inside an equation? And I think you guys will see this. This is going to be really a review again of algebra. If something is positive, if you have a positive number, so the absolute value of something is equal to a, then what we do is we split it off into two different possibilities. That technically the u is supposed to be the one that could be negative or positive, but what we do is we skip a step and we just put the negative on the a. So it's either a is a positive case or a is the negative case. Alright, if the absolute value of u is equal to negative a, then forget it. There's no way you can get a absolute value of something equal to a negative number. In that case, it's just a no solution. Alright, so let's go with it. Again, we're just going to handle 3 problems, let's see, maybe 4 problems, and just one of sort of each type from algebra here. So first of all, what happens when you have absolute value that's actually equal to 0? Well, in that case, how do we solve it? Is we just drop the absolute values completely. So if it's set equal to 0, just drop the absolute values and solve here. So I'm going to add 2 to both sides. We get x equals to 2. In this case, you only get one single answer, and the way it's written in back of the book would be something like this: set notation with a 2 in it. And then the next one, what we see from here is before we can split them off into a negative and positive case, we have to get the absolute value all by itself on one side of the equal sign. So in this case, before we even split it off, we have to add the 8 to both sides. Alright, now we can split it. So 6x minus 3 is equal to a 9, or 6x minus 3 is equal to a negative 9. And we're going to solve each of those cases. So adding 3 to the first case gives you a 12, divided by 6 should give you just a 2. On the other one, adding 3 to both sides should give you a negative 6 this time, divided by 6 gives you a negative 1. And again, you probably should try these by yourself if you can before, so you're just sort of just not copying me. But maybe at the beginning of each problem, try it yourself first, and then once you sort of got a little bit ahead, or once you finished off the problem, then turn on the video to see if you are getting the same thing I'm getting. Alright, back of the book, it should say this right here in set notation: 2 and negative 1, and again, it doesn't matter the order that it's in. You could write negative 1 comma 2, that will be fine as long as you have both answers there. Alright, and how about this one here? What happens if you have 2 absolute values equal to each other? So what happens here? And usually, if you think about it, there should be 4 different cases here. There should be a positive case, should be a negative positive case, then should be a positive negative case, and there should be a negative negative case. But what really ends up doing is, if you think about it, if this is positive and this is positive, or if this is negative and this is negative, if we divide through by a negative, we get the positive case. So really, there's actually not 4 different possibilities, there's only 2 different possibilities. So x plus 2 is equal to x minus 3, and that's going to be, in a sense, the positive case or the negative case. That's this guy. Or, and what we're going to do for this one, we're just going to make one of them negative. Doesn't really matter which one, as long as you make one of them negative. So I'm going to make the right hand side the negative case, so negative of x minus 3. And again, solving each of those. And try it yourself ahead of me so you can finish it off. Alright, let me try it myself here. So subtracting x from both sides, and this is what happens. You have a case in which the x or the variable cancels off. In this case, there is no answer for this solution. But let's go to this one here. If there's a solution here, distributing the negative gives you a negative x plus 3. Then adding the x to both sides gives you a 2x plus 2 is equal to a 3. Again, subtracting the 2 then gives you a 1, then dividing by 2, how about just a 1/2? So the left hand side didn't produce us a solution at all, but the right hand side did, and the answer is 1/2. Alright, going on to the next problem here. What happens if you have a variable that is inside the absolute value, and then you also have a variable on the outside of the absolute value on the other side? So there's our problem. Our problem, x is, or the variables being in two different spots. N is it says here on the side. In this case, you always have to check. There's no way around it here. Once you solve for the problem or the solutions, they are only potential solutions. You got to plug it in to make sure they work. So again, always check for this case. Alright, so let's go for it here. So the absolute value is all by itself on one side, so there's no moving things around. So let's go for it. Drop the absolute value. Think of this as the positive case here. Or absolute value is dropped, but then we're going to negate or take the opposite of the left hand side or the right hand side. And again, if you think you got it, go for it. Try to solve each of these and then try to check it. You can pause the recording if you like, just to give yourself a head start. Alright, and in this case, I'm going to start it as well here, distributing the 2, subtracting 2x from both sides, and that should give us x minus 4 is equal to negative 2. Adding the 4 to both sides, eventually we get ourselves an x equals 2. On the other side, keeping everything the same on this side, and then I'm going to distribute that negative. So the negative really just goes to the 2. Notice this is the outside parenthesis, so the negative only goes to here. There's only one term in here. Alright, then now let's distribute the negative 2 as a negative 2. And we get ourselves a negative 2x plus 2. And shifting everything over to one side, getting the variable by itself. Adding 4 and then dividing by 5. So there it is. There's two answers, but those are only potential answers. We do have to check just to make sure they work. So let's check it. Check x equals 2. Alright, again, I'll let you guys check it first here, give you guys a little bit of a head start. Alright, and 3 times 2 is 6. 6 subtract 4 is a 2, and the absolute value of 2 is a 2 on this side. This one, let's see, inside parentheses, 2 minus 1 is a 2. 2 times 2 is 2. Voila, this one checks out in this case. The other case, 6/5. Plug in that, a little bit more complicated there. And again, give you guys a little bit of a head start to check it yourself. And what I did, I just made common denominators. That's the way I sort of solved it here. So inside the absolute value, I got 18 over 5, then subtract a 20 over 5. Simplifying that further so I don't have to work on both sides of the equation here. I got myself a negative 2/5, but then when we take the absolute value of it, it just becomes a positive 2/5. Going back up on the other one here, I think I'm just going to simplify the stuff inside the parenthesis first here. So 1 is really 5 over 5. And 6/5 subtract 5/5 would give me a 1/5. Multiplying that with 2 would give me that. Again, that one checks out as well. So final answer, though it would be written back of the book, would be 2, 6/5 in set notation. All right, really quick recap from algebra about absolute value equations, or equations involving absolute value. Well, let's move on to inequalities now. So inequalities, this is normally the way we do this in algebra. We have these little really quick set rules to solving absolute value. So the a has to be positive, first of all. If it's negative, then it doesn't work. Doesn't work in this particular rules here. So absolute value of u is less than a. If it's less than a or less than or equal to a, what we have ourselves is we have an and statement. And this is the short notation for and right here. If it's a greater than symbol or greater than or equal to symbol, then it's an or statement. And again, there's no short notation for or, so we're just going to write it like this. So notice how this sets out. It's u less than a negative a, or u is greater than positive a. So notice the sign is switched as well, or the inequality. All right, so let's try our hand in this here. So really the only question is it an and statement or is it an or statement? If it's an and statement, we do it the quick way in short notation. If it's an or statement, we take the long way and finish it off. All right, so look at this problem here. First question, of course, is this and or is this an or? It should be an and statement because, again, the absolute value is less than or equal to a certain value. So in this case, we drop the absolute value, put a negative 6 on the other side, and go back to the previous slide if you need to, or go back to rules in your book. Again, what we do is we take this value 6, we take its opposite, bring it over here. We get rid of the absolute value marker. So really what we're saying is this expression is stuck between a negative 6 and a positive 6. That's kind of what we're saying. All right, and then from algebra, we know that now we're going to work on all three sides, and you always have less than or equal to symbols or less than symbols for the short notation for and. All right, let's go for it here. So negative 6 subtract 3 is a negative 9. In the middle, now I just have a 3x. On this side, I got a 6 minus 3, or just 3. So dividing both sides by 3 gets us a negative 3 is less than or equal to x less than or equal to 1. Now eventually what we want to do is we want to put it into interval notation. And then you also want to graph it as well according to the directions here. So graphing this, finding our negative 3, finding our positive 1, and because it's an equal to part over here, we have brackets. And again, because the x is caught in between negative 3 and 1, we have ourselves the fill-in is between negative 3 and 1 on our graph. All right, interval notation. How does that look? There it is. It's bracket negative 3 going up to 1 bracket. All right, so let's have a little bit of time here. Let's see if we can do the word problem here. So we're trying to find the possible search range in miles for a search plane that has 30 gallons of fuel and uses 10 gallons of fuel per hour. The search plane normally averages 115 miles per hour, but that weather condition could affect the average speeds by as much as 25 miles per hour. So depending if you have a headwind or a tailwind, the airplane could actually be going slower or faster. So now we're trying to figure out what is that possible search area. Alright, and the book does hint at a certain formula that you can use, and here's the formula. It says the absolute value, actual speed subtract average speed is going to be less than or equal to 25 miles per hour, right? So we can go back and forth on that. Alright, so actual speed is just going to be x, because that's what we know. The average speed is going to be 115. So think about this right here. Is this an and or an or statement? Just like the previous example, or practice problem here, yeah, this is an and statement. So I have to take that 25, bring it over as a negative, drop the absolute value symbol, and then put the positive 25 and 1 in again. So we're this little symbol of x minus 115 miles is couched between negative 25 and positive 25. So it could either go 25 miles over or 25 miles under. That's kind of what we're solving for. And right now we're just looking at possible speeds of the airplane. So adding 115 to all three sides gets us now to this right here. So what is this saying? The lowest the airplane was going was 90, and the fastest, if it had a tailwind next to it, that means they were traveling at 140 miles per hour. So then we'll go actual speeds between 90 miles to 140 miles per hour. Again, you might see this also on if a hurricane is coming through or a tornado is coming through. They say, you know, this is the average speed, and then actual speeds are between this one and this one. That's kind of what they're measuring as well, how fast the tornado is cycling. But the only problem we have here is we need to figure out how many hours it flew, since we have miles per hour. So let's see. It had 30 gallons of fuel on the airplane. It was consuming 10 gallons per hour, so everybody okay with this one here? So that means it had a flight time of about 3 hours left of fuel. Alright, so if that's the case, then all we really got to do is do this here. We're going to multiply that previous inequality that we had by 3 everywhere. So again, now we're looking at time values based upon the 3 hours here. So there it is. Our search area is going to be anywhere between 270 to 420 miles. There's my search area. At least hopefully that was a pretty good example there. Sort of seeing how inequalities can give you some idea on the real world of things here. Alright, let's go do another one here. And of course, if that was the and, this one has to be the or statement. So if you think you got it, try it yourself. See what you guys get. Alright, yes, this is an or statement because the absolute value is greater than or equal to 6. So now what we do is we drop the absolute value, write the positive case here, or what we do then, we write the negative case. So again, what we do is we switch the inequality and make the 6 into a negative 6. Solving each of these here, subtract 3, divide by 2, will give you that. On the other side here, when we subtract 3, we're going to get ourselves a negative 9, divide by 2 gets me a negative 9 halves. Alright, then we're going to graph this. So set up a little number line. 3 halves would go here, and negative, let's do this one as well here. So x is greater than or equal to 3 halves. That means that has to be a bracket, and then also because we're looking at x greater than, it's going to go off to the right. Looking at negative 9 halves, again, it's x less than or equal to negative 9 halves. That means it's going to be a bracket, and now it's going to move off to the left. But at the final answer, what we really want is we want interval notation. We want to be able to answer this as an interval. So how about -infinity to -9/2 bracket? And again, that union, because there's a little gap in the middle. Got that union, then we go from 3/2 off to positive infinity. All right, now let's take a look at two special cases. We're going to take a look at two special cases, and then we'll do a little tough problem here to finish off here. So special case. Why is this a special case? Is because we have a -3 in our hands. All the rules that we have only work for positive. If this was a +3, then we'll just keep on going. But because it's a -3, before you split them off into different pieces, you got to think about this here. And the thinking should go like this. If the absolute value is always going to return to us a positive number, when is this true? When is a positive number going to be greater than -3? Think about it in a number line. Think about all the positive numbers on a number line. And positive numbers, hey, all the positive numbers are greater than -3. Okay, so if that's the case, then we have ourselves all real numbers. So all the time, there's never a time where positive numbers will be less than -3. So positive numbers, so if you have an absolute value that's greater than some kind of negative number, the answer is all real numbers. How do we answer it in interval notation? Well, we'll go from -infinity to positive infinity. Done. All right, let's look at the other case. And you can kind of tell what's the difference between A and B. So now we have the absolute value of something being less than or equal to -1. And again, still the same process applies. We know the absolute value is always going to give us a positive number. And so now the question is this: when is a positive number going to be less than or equal to -1? Positive number less than or equal to -1. Hey, that's never going to happen, right? Because all positive numbers are always greater than negative numbers here. So in this case, we've got ourselves no solution. Symbol for no solution, there it is, 0 with a slash through it. Okay, so again, those are the special cases here. Let's go on then to the tough problem here. This is the tough problem. Alright, how do we handle this? So we got absolute values, two absolute values, and then we got ourselves an inequality here. How do we do that? Alright, so first things first, we have to get the absolute values all on one side of the equal sign. Now the only thing is when you start dividing like this, we got ourselves a little tiny problem. Because what is the only number that we cannot divide by with inequalities or equations here? We can't divide by 0, huh? Right? Because if this turned out to be 0, I couldn't divide this. So off to the side somewhere in your mind, just kind of think to yourself, okay, x cannot be equal to -4. There's never a time where x can equal -4. Because if it did, then we would actually be dividing by 0 here and 0 here. So kind of put that in the back of your mind. If you want to write it down somewhere, write it down. X cannot be equal to -4. Sort of circle it. Right, but with that, what we have this idea. So notice what I did is these were two different absolute values. One was the numerator, one was the denominator. What I did is I put them as one single fraction. And think about it, you can do that. If this is positive on top, this is positive on the bottom, then it wouldn't make any much difference if I simplified it and then took the opposite, or the absolute value of it. Okay, so this, finally, we got the absolute value on one side of the equal sign, or the inequality. So, and or, there's the question again. This is an and or statement. It is an and statement, so we're going to split it off like we did before. -4 less than whatever's in the middle, less than 4. Alright, the only problem here is this is going to be complicated to solve. So what we want to do, we can't really work on both sides because you can't really multiply by x plus 4 and start doing all that. That's not going to be possible. So we're going to have to split this off into two different pieces. So here's what we're going to do. We're going to take this piece here, the -4 less than our quantity. Then we're going to take our quantity less than the +4. So it kind of looks like this. See if we can kind of make sense from the previous slide. This is going to be a long one here. This is good of a challenge one here. Alright, let's start solving this side here. So, one little problem. We can't multiply by x plus 4 on both sides. Not with inequalities here. So what we're going to do, we're going to add 4. And we're going to start comparing it to 0, which is something we've done before. And also we need common denominators. So if this makes sense here, skipping a few steps here, but I think you guys can make 4 into a common denominator. There's a 4 multiplier now. This became 4 over 1. And common denominator is x plus 4. Distributing the 4 over here makes 4x plus 16. And finally, setting it as a quantity compared to 0 gives us 5x plus 14 on top. The other side, yep, and it's going to be about the same challenge here. So in this case, we're going to subtract 4 from both sides. Again, now comparing to 0, get some common denominators here, which is x plus 4. X plus 4 there, multiplying now x plus 4. And distributing that 4 so we can put the two fractions together. So on this one it would be, let's see, x times 4, x times, or 4 times 4 makes 16, still compared to 0. Common denominator is there, so x plus 4 there. Let's see, I got x minus 4x makes negative 3x, and negative 2 subtract 16 makes negative 18. So there are two inequalities, but now we've finally got them compared to 0. That's what we want to start with. In fact, keep on going. That's what we want to start with next. So let me rewrite these. Let me write this so far on the next slide here real quick here. This is what we have from the previous slide. And we're going to keep on going. So this one was in the algebra review section. How do we handle inequalities with rational expressions? So what we do is we pretend equal sign. Alright, start our little inequality here. First of all, again, we've got to think back. Remember how negative 4 could not be a solution already because we would be dividing by 4? Here with equal signs, we've got the same problem here because I want to multiply both of these sides by x plus 4. So I have to already designate the fact that I cannot have x to be a negative 4 because I can't multiply by 0. And so multiplying by x plus 4, still a 0 on that side. I got a 5x plus 14 left. Again, subtracting 14, dividing by 5. How about a negative 14 fifths? Alright, negative 14 fifths should be on the right hand side of 0. And what I'm going to do there, you can put a dot if you like. You can fill this in as well if you like. But we're going to pick test points here. I'm going to pick negative 5 as a test point to see if this is true and false for this inequality. And you're going to have to do the work yourself. I found that to be true. So if you plug in negative 5 into here, negative 5 times 5 is negative 25. Negative 25 plus 14 is negative 11. And negative 5 plus 4 makes negative 1. So negative 11 or negative 1 is a positive 11. So this is true. We've got to pick a number between negative 4 and negative 14 fifths. All right, I'm going to pick a -3. I think that's true. Plug in a -3 into that. I'll let you guys do that yourself, and you just have to figure out true or false. Again, in your mind, or plug it in on a sheet of paper here. Plug in -3 into here, -3 into there. See what you guys get. I got myself a, looks like that'll be a -15 on the top, a +1 on the bottom, so it makes a -15 overall, and that's false. So pick a test point that's higher than -4/5, and the easy one is 0. If you plug in a 0 in here, 0 in here, it makes 14/4, and we got ourselves a true statement. And the only thing I want to go back here is, are we including the -14/5 or not? Well, all dependent upon this sign right here. Got a less than symbol. The less than symbol, that means it's not less than or equal to. If it was an equal to symbol, we would have brackets here. But because it isn't, we got ourselves a parenthesis. We're not including this point here that causes the 0. But we are including everything else to the right-hand side. Okay, we've only solved one of these inequalities. I said this is a long one here. Let's turn our attention to this side over here. So let's make this into an equal sign. And again, start our number line here. Again, we have to put a little open dot at -4 because it cannot equal a -4, which allows us now to multiply by x plus 4. X plus 4, x plus 4. Cancel that off, gives you -3x minus 18 equals 0. Add 18, divide by -3, and how about a -6 for our final answer? Alright, if that is the case, we're going to go back to the number line over here, make ourselves a little -6. If you want to fill it in with the dot as well, that's fine. I want to leave it open because I want to see if I'm going to put parentheses or brackets here later on. Alright, just like we did before, we need some test points here. So how about a -7 or a -10, whatever you like, as long as it's less than -6. Plugging in a -10 into this. Let you guys do that, and again, I want to know true or false if I plug in a -10 into that. So -10 and -3 makes 30. 30 subtract 18 makes it 12. And -10 subtract 4 make a -6, and negative over negative is a positive over a negative is a negative, and it is less than 0. That is a true statement. I do want all that stuff there. Alright, to pick something between -6 and -4, which is -5. We're going to plug in -5, we're going to plug it into this one here. So again, try it yourself, plug a -5 into all this. I'll do it sort of verbally with you guys. So -5 times -3 is 15. 15 subtract 18 is a -3. So on top we have a -3. -5 plus 4 is a -1. So -3 over -1 is a +3. But is +3 less than 0? I don't think so. So that is a false right here. So then let's check anything that's higher than -4, and of course 0 works out perfect. Is plug in a 0 into here to -3 times 0. Subtract 18 is -18. 0 plus 4 is 4. -18 divided by 4, I don't really care what it is, but I know it's going to be a negative number. And I know negative numbers are less than 0. So I have all this area here. And since I'm not including my -4, again, that's going to be more like a parenthesis right here. Alright, so what we're going to do, because of this AND statement here, we're saying when is this true as well as this is true. When are both of them true at the same time? So let's make another number line. Bring it down only the times that we have graphed both of these to be true. So it looks like from -infinity, everything's true up until -6, not including the -6. Alright, then we've got some other, so we go that way. Alright, it goes up to -4, but there's only one line here, so at -14/5, again, it's both true again over here. So starting here, again, we need the parenthesis, and then we need to go off to positive infinity. So there it is. Whew. Again, a long problem here. These are all the problems. These are all the numbers that would make the practice problem number 8 true. Again, I know it took 3 slides here. That was a long problem here, but it was the challenge problem really of the day. All right, so putting this all together in interval notation, hopefully you figured out that it would be this here. So negative infinity to negative 6 parentheses, union, because we're taking out this whole entire middle section, and then starting again, it's true on both sides at negative 14/5. So we put parentheses and then going off to positive infinity. All right, so this concludes the lecture for 1.6.